Okay, so we're going to do the in-class review for college algebra. So the first one says to give the domain and range and determine if the relations are functions, state why or why not. All right, so let's look at the problem. So example 1. So if we're looking at our domain, remember the domain is the x values. So domain is going to be, slide this underneath here so you can see it while I'm working it. It's going to be with a curly bracket, not parentheses, because we're not doing ordered pairs with the domain. It'll be -2, 3, 6, 8, and 11. And the range would be 9, 5, 6, 1, and 2. So is it a function? Yes, it is. And why? Is because the domain, or the x value, does not repeat. So this is part A. Let's do part B. All right, so the domain is going to be -6, -3, and 4. 4 happens again. We don't write it when it repeats. Our range will be -5, -7, 6, and 8. Is it a function? No, because that 4 repeated, that means remember if it's a function, it only has one y value for every x value. So that tells me that it's not a function because my domain repeats. You can write domain or x values, either way, but the domain repeats. All right, next question, number 2. We need to find the domain of the functions and write in interval notation. So the first one we have g of x is 5x over x minus 7. So with that, we have to find the domain. So remember, when we're looking at domain, we're looking at dividing by 0 or taking the square root of a negative number. So we can't divide by 0 here, so we take the denominator, and we're going to take the denominator and set it equal to 0 and get x equal to 7 when we add the 7 to both sides. To find the interval notation, we'll put our infinities and we'll put our 7. Remember, this means it can be any number but 7, because when I plug in 7, 7 minus 7 is 0, and that makes me divide by 0. So that means it'll be everything but that, so it'll be -infinity to 7 union with 7 to infinity. Now, when you're doing the exam, you have to show these steps. This is what I want to see. So don't just tell me x equals 7. You have to show me, because I need to know that you have to set it equal to 0. All right, let's look at the second part of this, part B. So part B, we have h of x equal to the square root of 22 minus x. So we're going to take the part under the denominator, under the radical, and set it equal to 0. We can just add the x over, greater than or equal to 0. Not just equal, but greater than or equal to, because it can be anything greater or equal to 0. So now we have 22 is greater than or equal to x. So that tells me that x has to be less than 22. So I'm going to put it on my number line again. X is less than, so it's going to go to the left, and it's going to get a bracket because it's equal to. So it'll be from -infinity to 22 with a bracket. So any number 22 or below will be fine. Anything above 22 will cause us to divide by a negative number, which will be a problem. All right, so our next problem, number 3, says to evaluate the function at the given value and simplify. So we have a function here. Let's be problem 3. We have g of x is equal to x squared plus 4 over x minus 5. And we want to find g at negative 3. So that means we're going to have negative 3 squared plus 4 over negative 3 minus 5. Well, negative 3 squared is 9 plus 4, and negative 3 minus 5 is negative 8. 9 plus 4 is 13 over 8, and it doesn't matter where you put the negative sign. And that would be your final answer there. Okay. The fourth one, we need to determine algebraically whether the given function is even, odd, or neither, and we need to show work. Now remember, I've told you that if the exponents, we can look at the exponents to kind of know what we should be looking for. If both of the exponents are odd, it should be an odd function. If they're both even, it should be an even function. And if they're odd and even in there, then it's going to be a neither. But it says determine algebraically. That means you have to plug in negative x for each of the functions. So we'll work on number 4. So we have part A will be f of x is equal to x cubed minus 7x. So plugging in negative x, negative x cubed will be negative x cubed. Negative 7 times negative x will be positive 7x. Now, all the signs changed, so it will be odd because all signs change. All right, let's look at B. B is g of x equal to 4x squared plus x to the 4th. So find g at negative x. We get 4 times negative x squared plus negative x to the 4th. So negative x squared is going to get us x squared, and negative x to the 4th will still get us positive x to the 4th. So no signs changed from the original function, so that tells us algebraically it is even because no signs change. And then we'll look at the last one. So h of x is equal to x to the 5th minus x squared. So h at negative x is equal to negative x to the 5th minus negative x squared. Well, negative x to a 5th power is going to be, stay negative, so it'll be negative x to the 5th, and then negative x squared will become x squared, so it'll be minus x squared. So this one changed, this one stayed the same. So this will make this neither because some signs change. So that's algebraically. On the test, you have to show me algebraically how it goes. You can use the knowledge of the exponents to double check your answer, but you actually have to show me the algebraic, and if you don't, you won't get the points. All right, next question, number 5. We're going to use the graph to determine the domain and range and the x and y intercepts, and if it's a function, state why or why not to find the indicated value. So I blew the graph up so we can kind of look at the bigger graph, so it'll be a little bit easier to look at. So first thing we want to find is the domain. So we want to know what the domain is, and this is example 5. So our domain, both ends of our parabola are going on. We're going to assume that they go on. They don't always draw the arrows very well. So that tells me that our domain will be negative infinity to infinity. Our range will start from the bottom. Our range starts at negative 2 and keeps going, so it'll be from negative 2 to infinity, and it'll get a bracket on negative 2 because it touches it. And then we need to know the x-intercepts and the y-intercepts. So the x-intercepts, so this is at -1 and -2. So it'll be about -1.5, and then we'll call this one at about -4.5. So it'll be -4.5, 0, and -5, or negative, let's see, this is our graph, so -1.5, 0, because it's about 1.5 right there, because here's our axes right there. Our y-intercept is way up here. We're going to call it at the top that it is at 0.6. And then we were asked to find, oh, is it a function? Is it a function? Well, we would figure that out by drawing one vertical line somewhere on our graph, and it will only touch once. So we would say yes, and you actually have to draw the line on yours. If you don't draw the line, you don't get full credit. So draw the line. And yes, and you'll say why is because it passes. You can do the vertical line test as VLT. I'm okay with that. And then let's find the value at f at -3. So if I'm looking at the function and I go to -3 for my x value, if I come down, the value is equal to -2. And that's all we have to do for that one. All right, example 6. We're using the next graph here. So for this one, we are looking at determining if there's any max or min, and where the function is increasing, decreasing, or constant. We want to use interval notation. So let's find our increasing, our decreasing, our constant, and then we'll look for a max and a min. So increasing, remember, we start from this part of the graph and come over until we find that it increases, and we only use the x values. So here our graph is increasing from -2 to +2. So increasing will be -2 to +2. Decreasing started at -3 down to 2, or down to -2. So -3 to -2. The constant starts from -infinity and goes to -3. And it starts up again at +2 and goes to infinity. Remember, the constant is where it's just going along like a horizontal line. All right, now we need to know, do we have a max or a min? Well, a max, remember, it has to go up and then change for it to, from increasing to decreasing for a maximum, and I don't see one of those. A min is decreasing and then it goes to increasing, which is what would happen right here. So for the max, there will be none, and for the min, it's going to be at -2, -3. And that will be our min. And that's all you have to do on that question. All right, example 7. So on example 7, we are using the given conditions to write an equation in point-slope form and slope-intercept form. State the slope, the parallel slope, and the perpendicular slope of the line. So remember, the equation of a line is y minus y1 equals m times x minus x1. We are given that we have -4, 3 and -2, -7. So in order to do this, we need x1 and y1. Well, we've got 2 of those, so we can choose one of the points to use. But we also need to know the slope. We were not given the slope. So first we need to find our slope. So we're going to label our points. Now, all formulas will be available to you somewhere on the test, so make sure you're looking for those. Usually they're on the first page. So we're going to have our slope is y2 minus y1 over x2 minus x1. So we're going to have negative 7 minus 3 over negative 2 minus negative 4. Don't forget your negative signs. So this will be negative 7 minus 3 will get us negative 10. The double negative will make that positive, and negative 2 plus 4 will get us positive 2. Negative 10 divided by 2 will get us negative 5. So that gives us our slope. Now we can plug in everything that we have. So we'll have y minus, we need to choose which point. It doesn't really matter which point we choose. I'm going to choose the first point. It doesn't really matter, but the 7's kind of big, and these are a little bit more in the easier range. So y minus 3 equal to negative 5 times x minus that negative 4. The other thing is there's only one negative here. That one has 2. So y minus 3 equals negative 5. X minus a negative 4. That will become x plus 4. I'm going to take the time to rewrite that just so we can follow it easier. So y minus 3 equals negative 5x. Negative 5 times positive 4 will get us negative 20. Add the 3 over. We get y is equal to negative 5x minus 17. And that would be your final answer. You would get the same answer even if you used the 2 and the negative 7. All right, number 8. Number 8 tells us that we need to find the average rate of change of the function going from x sub 1 to x sub 2. So remember, our average rate of change is very similar to our slope. It's f of x sub 2 minus f at x sub 1 over x sub 2 minus x sub 1. So that'll be our rate of change. We are told that our formula, or our function, is f of x equal to 3x plus 5, and our x sub 1 equals 3, and our x sub 2 equals 4. So we will have f at 4 minus f at 3 over 4 minus 3. So I'm going to go find f at 4 and f at 3 and then plug them back in. So using my formula, plugging in the value for 4 for x, I will have 3 times 4 plus 5, which will get me 3 times 4 is 12, plus 5 is 17. And then plugging in 3, I get 3 times 3 plus 5. 3 times 3 is 9, plus 5 will be 14. So I can bring those values up here. So that'll be 17 minus 14. 4 minus 3 is 1. 17 minus 14 will get us 3. So 3 would be our final answer. All right, for the next problem, we are back to our graphs, and we are going to do some transformations. So use the graph of the function f to graph the function g. Explain in words how the graph transforms or shifts. So the first thing we're going to do, let me rewrite our function. So we are given that f at x minus 2 plus 4. It should be f of x. One second. All right, so this should be f of x equals, there's a typo there, x minus 2 plus 4. So what we need to do is talk about what happens here. So remember, when it's inside the horizontal, or it's inside the parentheses, it is a horizontal change. And so that tells us it's going to move either to the right or to the left. Because it's negative, it's actually going to go to the right. So it's going to go right 2 and then it's going to go positive. The outer part goes up and down, so it will go up 4. And then we're going to just make our points go the way that they are. So on this, we would go right 2 and up 4 for each point. So I'm going to use, I think I'll use the red. It might show up. So we're going to go over 1, 2, and up 1, 2, 3, 4. And then go over 1, 2, and up 1, 2, 3, 4. And over 2, and up 1, 2, 3, 4. And over 2, and go up 1, 2, 3, 4. And then we're going to connect our dots. So it should look very similar. I kind of curved my line in so it doesn't look exact, but you have to tell me in words, and then you have to show me it moved. Okay? All right, let's go to example 10. So for example 10, we are given some functions, and we need to add and subtract and multiply and divide, and then we're also going to do some composite functions. So the first thing we're going to do is write down our functions. We have f of x equal to 4x minus 5, and g of x is equal to 3x plus 3. And the first thing we're going to find is, let's do the subtraction. So f minus g, remember that is taking each of the functions and subtracting them. So we're going to take f minus our g. So that'll get us 4x minus 5 minus 3x minus 3, because we have to distribute the negative sign. Combine like terms, 4x minus 3x will get us x. Negative 5 minus 3 will be minus 8. And that's your answer. The next thing we're going to do is add them. So f plus g would be 4x minus 5 plus 3x plus 3. So we're going to combine like terms. So 4x plus 3x is 7x. Negative 5 plus 3 would be minus 2. All right, the next thing that we'll do is we will multiply. So f of times g would be 4x minus 5 times 3x plus 3. So we're just foiling, we're just multiplying. So 4x times 3x will get us 12x squared. 4x times 3 would be 12x. Negative 5 times 3x would be minus 15x. And negative 5 times 3 would be negative 15. So we got to combine like terms. So this would be 12x squared. 12x minus 15x would get us negative 3x minus 15. Let's double check and make sure everything's right. So we got 12x. Minus, so plus 12x squared plus 12x minus 15x minus 15. Okay, just making sure. All right, and then f divided by g would be 4x minus 5 over 3x plus 3. And that's all your answer would be. There's nothing more to do there. All right, let's go do the more complicated part of this, and that would be the f of g. So let me write my functions again. So f of x equals 4x minus 5, and g of x equals 3x plus 3. So we're looking for f of g. So f of g of x. Remember, that's where we're going to take and plug in g of x for f of x. So that's the same thing as f of g of x, or in this case, it will be f at 3x plus 3. So that means wherever x is, we're going to plug in that g function. So that means we'll have 4 times 3x plus 3 minus the 5. So 4 times 3x will be 12x. 4 times 3 will be 12 minus 5. Combining our like terms, we'll end up with 12x. 12 minus 5 will be 7. So 12x plus 7. All right. And then let's find f of g at 2. So f of g at 2. So if we've already had to find this, then we can just plug in 2 here. So it'll be 12 times 2 plus 7. So that will be 12 times 2 is 24 plus 7. That will equal 31. All right, let's go the other way. What if we're finding g of f of x? So that will be g of f of x. So that will be g at 4x minus 5. So wherever x is, we'll plug in that 4x minus 5. So 3 times 4x minus 5 plus 3. So 12x minus 15 plus 3. So 12x, negative 15 plus 3 is negative 12. And then if we want to find g of f at negative 3. So we'll have 12 times negative 3 minus 12. Well, 12 times negative 3 is negative 36 minus 12 will leave us with negative 48. All right, so our next question tells us to find the inverse. So we're finding the inverse of the one-to-one function. So we are given, so this will be example 11. We are given f of x equals 7x plus 2 over 5. All righty. So remember, with the inverse, we call it Freaky Friday. If you want to remember, it changes the things, and it's all about y. So f of x is y, 7x plus 2 over 5. Now we swap y and x. So x equals 7y plus 2 divided by 5. So we're going to multiply both sides by the 5 because we're going to solve for y. So 5x equals 7y plus 2. Subtract the 2 over. We get 5x minus 2 equals 7y. Divide by 7. 5x minus 2 over 7 equals y. And the f inverse of x equals 5x minus 2 over 7. Now, you have to show all of the steps. You can't just guess it. You've actually got to show the work in order to receive the full credit. So make sure you know how to do that. It's all about y. Remember the steps. First thing, f of x equals y. Second thing, y is equal to x. Then you solve for y. Or, yeah, you swap them. You swap the x and y. So swap x and y. Solve for y, and then y equals that f inverse of x. So you can swap y and x. So it's all about a y. Do something about y. You change it to f of x, then you swap it with the x, then you solve for it, and then it becomes the f inverse of x. All right, our next question is number 12. So for number 12, we are writing a formula for the general term, the nth term of the arithmetic sequence, and then find the 10th term in the sequence. So remember our formula here is a sub n equals a sub 1 plus n minus 1 times d. So we need to know what n is, we need to know a sub 1, and we need to know d. So the first thing we know is they want us to find the 10th term. That means our n is equal to 10. Our a sub 1 is the very first term in the sequence, so that's going to be 3. And our d, we have to find that. Remember, it's going to be the second term minus the first term. So it will be 12 minus 3, which equals to 9. So we'll find a sub 10 is equal to 3 plus n is 10 minus 1 times our d, which is 9. So that will be 3 plus 10 minus 1 is 9 times 9, which is 3 plus 81, which will get us 84. And that will be, so you have to do two things. You have to write the formula, and then you have to find the number. And you actually need to do it this way. Don't figure out, well, I've got those ones, I can just keep adding to get it. You actually have to use the formula to do it. All right, the next problem is number 13. Solve the geometric sequence problem. So Jennifer takes a job with a starting salary of $32,000 for the first year with an annual increase of 3%. Create a formula that can be used to calculate the salary in year N. What is Jennifer's salary in the 9th year? So you got to create a formula again, and then you've got to figure out her salary in the 9th year. So for our geometric sequence, our a sub n is equal to a sub 1 times r to the n minus 1. So we need to know what n is, what a sub 1 is, and what r is. So we are told that her starting salary is $32,000 and that she has an increase of 3%. That will be the R, and her N is the 9th year, so that will be 9. Remember the trick about the R. It's not just going to be 0.03, but we have to put the 1 in front of it, so it's going to be 1.03. All right, so let's set up our formula. So a sub 9, let's see, it told us to create a formula that can be used to calculate the salary in year N. So it'll be a sub n is equal to 32,000 times 1.03 to the n minus 1, if we're actually asked to set up that formula. Usually I don't ask you to do that, just do the formula itself. So that would be in any year, but we want to find year 9. So a sub 9 equals 32,000 times 1.03 to the 9 minus 1. Now, I've told you before, take and do your exponent first, because sometimes the calculators are different. So 9 minus 1 will get you 8, and then when you plug that into the calculator, you should get 40536.64. So in the 9th year, she's making $40,536.64. All right, let's look at number 14, the piecewise function. So we've got a cab company that has the following rate schedule for travel in the city. They have a basic charge of $7. The first 4 miles are free. Over 4 miles of use, it's 50 cents a mile. Construct a piecewise function that relates the charge C for X miles of travel. Use it to find the cost for 4 miles of travel and 13 miles of travel. All right, so this is number 14. So we're writing a cost function. They actually said C. And we're told that the basic charge will be $7, and you have to use that in both cases. And the first 4 miles are free for that $7. So this would be if between 0 miles and 4 miles, even if you just have the X is less than or equal to 4, I'm good with that. But that way you understand. Once you get in the cab, you're paying some money if you just go down the block. you're going to pay some money. And then it's 50 cents a mile after the 4. So plus, it will be 0.50, 50 cents, times x minus the 4 miles that are free. So don't forget that part. You don't want to pay for those 4 miles because they were free. And this will be if from the 4 your x is greater than that. Now, it asked us to find at 4 miles, what is the charge? Well, at 4 miles, that includes 4 miles, it's going to be $7. For 13 miles, we have to use the second part, so that'll be 7 plus 0.50 times 13 minus 4. We plug in the 13 for the number of miles, and that will get us 7 plus 0.5. 13 minus 4 is 9. So that's 7 plus 0.5 times 9 would be 4.5. So we'd end up paying $11.50. So those are your answers. So make sure you've studied. You've got your own review to work out, so work that out. And the formulas will be on the exam.